Have you ever stretched a rubber band? You pull on it and it gets longer. That's stress and strain in action. Stress is the force you put on something, like pulling on that rubber band. Strain is how much it changes shape, like how much longer the rubber band gets. Stress and strain are everywhere, even in buildings. Buildings have to hold up their own weight, plus the weight of people and things inside. All that weight creates stress on the building materials. The materials then strain a little, changing shape slightly to handle that stress. Think of a concrete column holding up a roof. The weight of the roof pushes down on the column, causing stress. The column gets a tiny bit shorter because of that stress, that strain. Don't worry, it's designed to handle it. It's like a strong handshake. You squeeze a little and the other person squeezes back. That's stress. Your hands might change shape a little bit. That's strain. A good handshake has the right amount of both. Buildings are like giant puzzles, with different parts working together to handle stress and strain. Imagine a simple house. The walls hold up the roof keeps out the rain, and the foundation keeps everything from sinking into the ground. Each part of the house experiences stress and strain differently. The walls have to be strong enough to hold up the roof, so they experience compression, like when you squeeze a marshmallow. The roof itself might bend a little under the weight of snow, experiencing both tension, stretching, and compression. The foundation is super important because it spreads the weight of the entire house over a larger area of ground. This helps to prevent the house from sinking unevenly. Think about standing on snow. If you wear snowshoes, you sink less because you're spreading your weight out. Engineers use math and science to figure out exactly how much stress and strain each part of a building will experience. They then choose the right materials and designs to make sure everything is safe and sound. Just like you can stretch, squeeze, or twist that rubber band, buildings experience different kinds of stress and strain. We already talked about compression, which is like squeezing. There's also tension, which is like stretching. Think of a suspension bridge, with its long cables hanging across towers. The cables are under tension, being pulled tight by the weight of the bridge deck. The towers, on the other hand, are under compression, being squeezed by the force of those cables. Then there's shear stress, which is like when you try to slide two objects past each other. This happens in buildings during earthquakes, where the ground shakes and tries to move the building's foundation. Engineers have clever ways to design buildings that can resist these forces and keep everyone safe. Knowing the different types of stress helps engineers choose the best materials and designs for each part of a building. It's like choosing the right tool for the job. Picking the right stuff for the job. Just like you wouldn't use a hammer to cut wood, you wouldn't use just any material to build a skyscraper. Different materials have different strengths and weaknesses when it comes to handling stress and strain. Steel is incredibly strong under both tension and compression, making it great for beams and columns. Concrete is fantastic at resisting compression, which is why it's often used for foundations and walls. Wood is lightweight and surprisingly strong for its weight, making it a popular choice for framing houses. Engineers consider all these factors, along with things like cost and environmental impact when choosing materials. They even think about how easy a material is to work with and how long it will last. It's like baking a cake. You wouldn't use salt instead of sugar, right? Each ingredient has a specific purpose and works together to create something delicious and structurally sound. Staying safe engineers to the rescue. Building a safe and strong structure is a bit like solving a puzzle. Engineers are the puzzle masters, using their knowledge of stress, strain, and materials to make sure everything fits together perfectly. They use special computer programs to design buildings and test how they'll hold up under different conditions, like strong winds or even earthquakes. They also make sure that the materials used are strong enough and that the connections between them are secure. Think of it like building with blocks. If the blocks are weak or not connected well, the whole thing can topple over. Engineers make sure that our buildings are strong, stable, and safe for everyone inside. So next time you walk into a building, take a moment to appreciate the hard work and science that went into making sure it stays standing. It's a testament to the power of understanding stress and strain.